Now, in this shaded box, they give you a wonderful, confusing looking formula to figure out all the stretches and compressions. Off to the side, we're going to just write a simpler way of describing this. We're going to do all the transformations from left to right. That means that you do all your stretches first, then translations after. Stretches, reflections, any kind of thing that you're going to multiply by, you're going to do that first, and then your translations afterwards. But if you find it really easy to remember this, Ixabahuayak, that's just like, oh, that was my name of my grandma, so that's easy, then that's fine. But I think you'll find it, most of you will find it easier just to think, okay, I just need to do things from left to right. And when doing things from left to right, we always write the y by itself. Notice this one's in factored form. So we're just going from left to right. So in our next example here, the first thing I'm going to do is I'm going to write the y by itself. So I have f 1/2 x plus 1 minus 4. Couple things I look at. Do you notice that this one is in factored form? Okay. One of the things I like to do when I'm writing more than one set of brackets, notice how I made big brackets and little brackets? So I knew that, oh, the little bracket ended with the little bracket and the big bracket ended with the big bracket. Can help you visualize that a little bit better. If we go from left to right, we can label things. Can you see this is inside, so it's going to be a horizontal stretch. You're going to multiply x by 2. This is a horizontal translation, 1 to the left. And this is a vertical translation, 4 down. Okay. On this original graph, I'm going to take a couple of points. I'm going to take 1, 1. I'm going to avoid 2, 0.5 because it's a fraction. I'm going to take -1, -1. And I'm also going to look at my asymptotes. This equation has an asymptote at x equals 0 and 1 at y equals 0. And I'll show you how to do the asymptotes after we're done the points. So here's setting up the points. We're going to go from left to right. We're always going to do our stretches and compressions first, then our translations. So in this graph above here, I know that I need to multiply x by 2. For translations, I need to go 1 to the left and 4 down. So now I can do my points. Again, the math is easy, but make sure you're multiplying the right points. Make sure you're checking as you go along. Multiply my x coordinates by 2. Now I'm going to go 1 to the left. So that'll go to 1 and to -3. And 4 down, -3 and -5. And we're going to do the same thing to our asymptotes. First of all, since your asymptotes are at 0, can you see multiplying x by 2 isn't going to change anything? Also, multiplying x by 2 would never change the y equals 1. It would just change the x equals 1. So the only thing that's going to change these asymptotes is moving it up and down, left and right. When I move it 1 to the left, which one changes, the x equals or the y equals? The x equals. Because that one's here, I move it 1 to the left, it's now going to be at x equals -1. When I move it 4 down, that's going to affect the y equals asymptote. That's going to move it down 4 to y equals -4. On a number of graphs, if you try to graph both of them on the same graph, they get really busy, especially with the asymptotes in this one. So I would suggest when you go to graph, you make a new grid. So here's my new grid. Draw your asymptotes in red. Y equals -4. X equals -1. Label your points. So the 2 points that I have are 1, -3. And -3, -5. Draw your graph towards your asymptote. And we've got the same shape as before, but it's been horizontally stretched by a factor of 2 and translated left and down. So again, going from left to right, no problem, and then being able to take your new points and put them on your graph will draw your new graph. For part B that isn't written in yours, I want you to write the explicit equation of this new graph. So here's the new graph. First of all, did you recognize the original graph? It just gave us function notation, but the original graph, f of x, is really what? It's the 1 over x graph. So one of the ones we did originally. And now we want to find out the explicit equation for this graph that had 1/2 x, what was it again? We wrote it out, x plus 1 minus 4. So again, this is just practice changing from function notation to explicit notation. We knew that our original function was 1 over x. But now inside of the original function we have this. So the new equation, instead of 1 over x, you would now have 1 over 1/2 x plus 1. Can you see that this part is now inside the function? And so it replaces, right? Here's your original function. It was just an x inside the function with an x on the bottom. And now we replace that with a 1/2 x plus 1, so that 1/2 x plus 1 goes on the bottom. Can you see the minus 4 is outside of the function? So that would still appear just outside of the function. So we got this question by having the original graph given to us in function notation and being told what to do in function notation. You could have had this same question without the graph and just the explicit equation. If you got this equation in blue, you would have to recognize it's a 1 over x graph and draw the 1 over x graph on your own. Where the asymptotes are, what are the important points? Then you'd have to recognize that where the x was originally, you have a 1/2 and an x plus 1. So this is all inside the function. And I think the 1 over x graph is the hardest one to see what's inside the function. But basically what you're just looking for is what's where the x used to be. Because where the x used to be is inside the function. So in a 1 over x graph, the x is in the bottom. Now I have a whole bunch of stuff on the bottom. That's all going to be horizontal stretches, reflections, translations. Then I have a -4 outside of that. That's going to be vertical. Okay, questions to do on this one. Brought to you by Slurpees, 7 and 11.